Hey Goose, it's Captain Al for Goose's Guidance Part 2 on your Odyssey to Miami on the Boeing 747-400. So let's get started with some questions. And they were good questions, by the way. The thrust lever angle graduation marks are, I even forgot they were there. You know, I had to go look for them because I didn't even remember them. So you kind of look through those because they're not used operationally by the crew. It's a maintenance function primarily to check the thrust lever angle against the resolver or potentiometer or however the heck they measure that. It's not a linear progression from 0 degrees idle thrust to 85 degrees at the full travel. So they have those graduations on there primarily to check whatever test they do to check the thrust lever angle. So it's nothing that we use. However, we do use the primary ICAS for setting the initial thrust for spool up stabilization before we hit toga. So in order to do that, we use the I forget what that's called. It's a little thrust indicator or thrust vector indicator. I don't know what it's called. But when you move the thrust levers, there's a little horizontal hash mark that shows where you're moving the thrust lever. And so we can take that indication with all 4 thrust levers, and we can move it up to approximate 70% N1. And to do that, it's there's a little N1 indication on the primary ICAS, and if you put the indicator just below the N1, that's pretty close to 70%. And let me demo that here. I think I got AeroWinks open, so let me look at that here and show you what I mean. I don't have all 4 thrust levers hooked up here, but I'm in a 2-engine configuration, but one of my thrust levers is hooked up to engine number 3. So you can see right here on the, if you can see my pointer, right here on engine number 3, there's this little hash mark that shows where the, right now we're at idle thrust. And if I move that, you'll see it move. You can see it going up and down. And if I move that thrust lever to just below the N1 indication, that'll be 70%. Now I notice in the AeroWinks it's actually a little bit less. It seems like I would go up to, from what I remember, I think I would go up to about 75% N1 where it looks in the simulator in the airplane. So if I move it up like this, I'll move it to where I think it is with AeroWinks. Let's see where it goes. It's a little shy there. There's about 70% right there. And that's not quite under the N1. If I were to approximate where it is, where I think it is in the simulator, I think it'd be right about here probably, where 75% is. That's kind of what it is, but in AeroWinks it's down here a little bit. At least that's what I remember. I could be off on that, but this seems a little shy to me, this 70%, where that is. But that's where it is on AeroWinks. And in the simulator, I think it'd be more like this. More like up to 75%, or kind of just under that N1 indication. So you bring all 4. I could bring this other one up, I think. Yeah, there it goes. So you'd bring all 4 up to that, you know, approximate that 75%, or in our case, 70%. So if I bring it down a little bit, so for AeroWinks, it would be, you know, right in here, right in there, and that's probably pretty close. I may be underestimating this, but it's right. You know, it's just under the N1, and you'll get the feel for where that is certainly. Let me close AeroWinks. And let's go back to the PowerPoint. Okay. If a problem occurs, you silence the master warning and caution whatever it may be, identify the problem. Captain decides who is flying the airplane, and then the pilot monitoring is directed to the appropriate checklist based on the ICAS message. Who handles the radios? That was the question. In the past, the pilot flying would handle the radios. So he would say something like, I'll fly the airplane, you get out the checklist for blah, 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 and I'll handle the radios. Well, we really don't say that anymore because it has changed to the pilot monitoring, handling the radios, even when he's doing a non-normal checklist. However, the pilot flying has to manage the automation, the flight path, and the configuration. So his main job is just fly the airplane. His job is really not to communicate. So officially, yes, the answer is the pilot monitoring handles the radios even during a non-normal. So that's different than the way it used to be. But there's a but here. Task management and saturation workload and phase of flight have to be considered. So you have to kind of gauge who's getting saturated. Is the pilot flying getting saturated, or is the pilot monitoring getting saturated based on the problem in the phase of flight? So if the pilot monitoring runs the risk of losing place in a paper QRH by handling the radios, then it may be better for the pilot flying to take the radio. If the pilot flying runs the risk of losing flight awareness, then it's control and things like that, then it's better that the pilot monitoring handles the radios. So if you're saturated with either pilot, if they're saturated during a critical phase, then that can kind of also determine how the radios are used. So it's not a hard and fast rule. So you have to kind of consider where you are and how potentially saturated are you. If it's a cargo fire at 15,000 feet, that's going to be different if it's an engine failure at V1 and the pilot flying is maintaining control and rotating and positive rate gear up, and now he calls for memory items for engine number 1 for a fire or whatever. It's reasonable then for the pilot flying to take the radios in the case of the cargo fire, but it's probably also very reasonable for the pilot monitoring to handle the radios for a V1 cut, or at 1,000 feet when the pilot flying is getting everything situated and retracting flaps and calling for a checklist. It may be better at that point for the pilot flying or the pilot monitoring to handle the radios, unless the pilot flying gets into a workload situation where he feels things are less saturated, and then he'll handle the radio. So it's not a hard and fast rule, but officially the pilot monitoring, that's his duty to do the radios during a non-normal. But other aspects have to be considered. And that runs into, CRM and situational awareness and, how what's developing and who's saturated. So the bottom line is the pilot monitoring does handle the radio. That's his job, even during a non-normal. But the pilot flying can relieve the pilot monitoring of those duties as long as the pilot flying is in a position to do just that. And that means he's not saturated, he or she. Souls on board, number of fuel, souls on board and the fuel on board. Yes, that's given in hours, as you said. We use 20,000 pounds an hour if you're cruise. If you're, at lower altitude or heavy, you could consider using 25,000 pounds an hour. So generally it's 5,000 pounds per engine. If you're up higher, then you could use that 20,000 pounds, so 80,000 pounds would be 4 hours of fuel. Or if you're using 25,000 pounds an hour because you're lower or heavier, then you could, shorten that time up to 3 hours and 10 minutes or whatever. And maybe even add a buffer to that if you wanted to. But, or maybe be more conservative with it, actually. So generally it's 20,000 pounds an hour. Down low, something happens, we'd use 25,000 pounds an hour. And divide that by your fuel, of course. Turn the standby power and the battery off during an emergency evacuation. No, we don't do that. We definitely don't do that because, number one, the checklist doesn't call for it. And number two, the hot battery bus is always powered regardless of the battery switch. So even if you were to turn off the battery switch, then the hot battery bus would remain powered. And that's where the things like, the cockpit voice recorder and emergency lights are usually self-contained batteries. But, the only reason that I can really think of that we don't do that is because it'd be a waste of time. Those actions are not needed to do. If you took the time to do that, it's two more things that you're doing that you don't need to really be doing. Because it doesn't matter whether the battery switch is on or off, because those critical items are on the hot battery bus anyway. On takeoff, I think the question was, you said, why don't we say setting takeoff thrust instead of set takeoff thrust? It's a challenge and response idea. So the pilot monitoring, and the pilot flying says set takeoff thrust, and that's kind of the challenge. And then the pilot monitoring will check that the thrust levers advance and that the thrust is set by 80 knots. And then when the pilot monitoring sees the thrust is set by 80 knots, then he will say takeoff thrust set. And then 80 knots, check. So it's probably going to be set before 80 knots. And so again, the idea would be that the pilot flying sets the N1 at 70% for the GE engine, stabilize, and then push toga, and then he says set takeoff thrust. And then the pilot monitoring will monitor the engine instruments. When the thrust is set, he'll say takeoff thrust is set, and then he's going to call out 80 knots, and the pilot flying will say check. The question was, how long do we add forward control column pressure? And we add light forward control column pressure, and that's mainly for directional control and positive nose wheel steering. The rudder, of course, becomes effective between 40 and 60 knots. We get throttle hold at 65 knots where power is removed from the servo motor. And so at 80 knots is where we release the forward pressure on the control column, because by that time you have good rudder control and you've got positive directional control as well. V1 is the takeoff decision speed, as you know. Generally, the pilot monitoring is going to call out V1 about 4 to 6 knots prior to V1. And by the time it gets out of his mouth, you're going to be at V1. And at V1, your hands come off the thrust levers. And the whole idea of that is you're committed to flying at that point and getting airborne. So your decision is to go at that point. And so there's no temptation to, reach up and bring the thrust levers back now. You just don't remember. You did do this on the 757 and 767 at UPS. So normally the captain, if the first officer is flying, then he's going to set the power and, call for EPR on the 7.5, and then the thrust levers will come up. And as they come up, the first officer's hands come off and the captain's hands go on. And then, of course, at V1, the captain's hands are going to come off. If the captain's flying, of course, he does all that himself. Then his hands will come off the thrust levers at V1. So again, it's the whole thing of the takeoff decision speed. And I know in did I mention that here? I know that sometimes in general aviation and in corporate, a lot of times your hands do remain on the thrust levers. So this is more of an airline deal as far as taking your hands off the thrust levers. But you definitely did at UPS. You probably just don't remember. Recirc fans, there are no recirculation fan switches on the freighter. You do have recirculated air on the freighter. It's just you don't have those recirc fans that you're referencing, the upper and the lower recirc fans for the passenger version. The passenger version has more regulated air because you have a bunch of people, and so you need to recycle that air, and then there are switches for that. And of course, depending on phase of flight, will depend on which recirc fans are on, either 2 or all 4. And in cruise, pretty much all 4 fans are on, and during the climb, maybe only 2 are on. But in the freighter, it's pretty much automatic. There's no 4 fans like the passenger version. You do have a flight deck fan switch on the freighter that controls your ability to get more air circulated on the ground in the flight deck. Doesn't work in the air, but on the ground. And then, of course, there are high flow switches. There's a main deck and lower lobe switches to control the temperature of the air, and then trim air switches. But the recirculated air is pretty much automatic in the freighter. You just don't have those switches you have on the passenger airplane. The forward E&E bay is under the flight deck. That houses, a lot of the avionics stuff like FMCs and FCCs, flight control computers, stuff like that. There also is an aft E&E bay that's way back by the pressurized bulkhead, and the things like the APU battery are in that. It's a smaller unit than the forward is. There's also a smaller middle bay that's not really recognized by pilots, but the engineers and mechanics know of it, and it's really not that easy to access. But we're only taught the forward and the aft E&E, just those two compartments. The pilot monitoring duties when entering the departure runway would be to do those things, and he can do them automatically. So, once you're cleared to line up and wait, runway 30 left, then he could bring on the strobes and transponder to RATA. And with Boeing, he can do that automatically as procedure. But many times the captain's going to say line up items, and then the first officer will just, spring into those. And then, of course, when we're clear for takeoff, then the pilot monitoring will put the inboard landing lights on. So a lot of people have heartburn with that, especially pilots coming from different airlines, because that's always the captain's domain to put the landing lights on. And so they say, they'll be kind of like, why am I letting him put the landing lights on? I mean, I'm the captain. I should be putting those landing lights on. Well, it's just Boeing procedure. It's the Boeing procedure that the pilot monitoring, and in this case, it's actually, I should say FO. There should actually be not pilot monitoring, but FO would put the inboard landing lights on, because at this point he's still, let me think about that. No, it is pilot monitoring, yeah, because you're moving the airplane. So the airplane's been moving, so it's whoever's flying, and that could be the first officer, and then the captain will be the pilot monitoring. So yeah, when the airplane moves, then that captain FO duties switch to pilot flying, pilot monitoring, depending who's flying. So, but a lot of people think the captain should be the one to do that. They're my landing lights. No, well, in Boeing, it's the pilot monitoring, puts the inboard landing lights on. So you just have to appease some captains on that. And you said, yeah, it's pretty quiet, in terms of through the after takeoff checklist. And that's true. The only communications during taxi are pretty limited. We brief, normally at the gate. And if there's added briefing items that are needed, then those would be, if there's some amendment to the departure, then we would review them, prior to takeoff. And so that would be talk that's required. Otherwise, it's pretty limited. The attention is mainly on taxi as you progress. And about the only thing, we say is that as you're, getting close to the end of the runway and getting ready to go, this is probably all you're saying is, I'm going to be in weather and you'll be in terrain. Before takeoff checklist. Before takeoff checklist, flaps, 10. Before takeoff checklist complete. And then you're calling the tower and line up and wait, and then you launch into the lineup items. So yeah, not a lot of talking is done in the taxi phase. Autopilot selection really doesn't matter. However, normally the captain, we say at Boeing, could be left or center, and the first officer could be right or center. And although, it wouldn't matter if the captain selected the right autopilot. It's just this is really technique. Lots of folks like the center autopilot command because that way it exercises or shows all three flight control computers. So the PFD on the captain side is the left FCC for the flight directors, and the PFD on the first officer side is the right FCC for the first officers, flight directors, and then the center autopilot will be going to the center FCC. So in essence, you're kind of exercising all three FCCs by going center autopilot command. So that's why a lot of people like to do that. But again, it's not necessary to do that. Again, for us, it'd be left or center for the captain, right or center for the first officer. Above 270 knots or 0.82, of course, you don't want to extend the landing gear because that's a limitation. But if you did, and that was kind of your question, yeah, it would be slower, but it'd also be riskier because of the air loads that can, So the gear would come out, but it's doing a lot of stress on the doors and the gear, and so you could have doors ripping off and things like that. It would be slower, though, the gear coming out. And then you asked about times. The normal gear extension, the ballpark is around 20 to 25 seconds for normal gear extension, and alternate gear extension is not that much longer. It's about 30 to 40 seconds. And the alternate gear kind of comes out in stages. It's kind of I can't remember which comes out first, but the nose and body gear will kind of come out, and then the nose gear will come out after the nose and body gear are down. Or the wing and body gear, sorry. When the wing and body gear are down, then the nose gear is in transit and coming down. So yeah, it takes longer, but really not that much longer. The main thing is the flaps are longer when you're doing like a hydraulic problem, especially between 1 and 5. That takes like almost 4 minutes, 3 minutes and 45 seconds. So that's not, that's the most time that you're concerned with as far as planning goes. Because then from 5 to 10 and 10 to 20, it's longer, but it's not that much longer. And same thing with the gear. It just takes time to read the checklist, so you still have to lead it by a little bit. But you do the checklist, and then you're extending the alternate gear, and it's going to take a little longer to come down, but not all that much longer. You mentioned on the scenario, I think it was Boeing Field, and on the climb page, I had 11,000 feet in the cruise altitude on the VNAV climb page. And if we take off in VNAV, and let's say we're limited to 7,000 feet, then as we approach 7,000 feet in VNAV, we're going to go from VNAV speed to VNAV alt. And that's because you have an intermediate level off, meaning that you're not at your cruise altitude. So anything where you're not at your cruise altitude and there's no restriction, but it's an MCP altitude, then you're going to get VNAV alt. However, if we then continue to climb to 1,000 and we level off at 1,000 because that's our program cruise altitude, then we're going to get VNAV path at the program cruise altitude. The other time you can get VNAV path is if you were to level off at a legs page constraint. So let's say, we take off and we go to 7,000, but there's also a restriction at 7,000, not just that ATC told us to maintain 7, but there's also a restriction to, cross XYZ waypoint at 7,000. In that case, as we approach the altitude, the airplane will go into VNAV path and not VNAV alt because you have a restriction on the legs page. So those are some of the situations where, VNAV alt versus VNAV path. Selecting flight level change. That'll give you whatever your target speed is at the time you push it. So if you were accelerating, let's say at 222 knots, and you push flight level change, but the commanded speed is 250, then the speed will be set to 250 on the mode control panel. And that's different than the 7.5 or 7.6, where if you were to go to flight level change in that airplane, it opens to your present speed. So it would open to 222, or it'll go to 222. Whatever your present speed is, it's gonna be at that speed. And then if you wanted 250, you'd have to bug it up to 250. So in the case of, if you're climbing out and you're more than 250 knots, then your target speed would be, let's say, 260 knots because of weight. Then if you were to go into flight level change, the speed would go to 260, even if you're at 242 knots and accelerating. And that's good because you don't want to have to set it again. That way you don't have to set it a second time, if that's your desired speed. Let's see. Your next question was extending the speed brakes. There is no ICAS message unless the boards stay out and you capture an altitude and you start leveling off and the power starts to come up. Then you get the speed brakes extended ICAS message. So yeah, during extension, no, there's no message. But if you were to forget about them, of course, we always recommend you keep your hand on the speed brake lever when you're using it. Don't take your hand off it. But in this airplane, if you did forget it, as the airplane levels off and adds power, you're going to get a message, a caution message. Beep, 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 beep. And you'll see speed brakes extended. And then you mentioned these scenarios. In vertical speed, there is no protection. So there's no pitch protection or thrust protection. So if you improperly use vertical speed, then the airspeed can deviate from what you want. And then it could deviate to the point where you get a stall, or it could deviate to the point where you get an overspeed if you let it get that extreme. So the main point is using VS, using vertical speed, there's no protections at all. In VNAV and flight level change, on the other hand, you have speed, gear, and flap protections, and you get those by either pitch through the elevator or auto throttle through the thrust levers, depending on what's controlling speed. Is the elevator on speed? Is the elevator controlling the speed? Or is the auto throttle controlling the speed? Like if you're in a VNAV climb, then the elevator's controlling the speed. Same thing with the flight level change climb. And in that case, the pitch would try to keep you from exceeding a limit. If you're in level flight, then the auto throttle is going to power back or add thrust in order to keep you at a limit based on speed, gear, and flaps. After landing procedure, but there's no after landing checklist. Yeah, that's correct. That's Boeing. That is Boeing. Yeah, the idea is that the attention factor after you go from flight mode to ground mode is kind of significant. And you know, it kind of is. You're flying, you're busy, you're being vectored, you're configuring, you land, and all of a sudden you're off the runway. And you know, now it's ATC's yakking at you where to go, you know, after you contact ground. And so I see Boeing's rationale in that. They make it a procedure only. In this way, you don't have to kind of go to a checklist and verify that, where you're kind of heads down while you're doing the checklist. Many airlines, however, don't like that, and they say, no, I'm not going to do it. And they'll add an after landing checklist. So Boeing procedures, yeah, there's no after landing checklist. It's just a procedure. And it's mainly just the FO. I think the captain gets a speed brake, and what else does he get? Speed brake and the maybe the weather radar or something like that. And I think that's it. That's all he does. Maybe the auto brakes, if the auto brakes are on the center pedestal. Otherwise, if the auto brakes are on the back, on the not the forward instrument panel, but the center pedestal, then it would be the first officer getting the auto brakes. So the captain has very limited duties. Everything else is the FO. And again, procedure only. You don't need to part the ILS. Again, that's pretty automatic anyway, how these things tune and stuff like that. Trim, yeah, not in most airplanes. However, yes, if it's a passenger airplane that has horizontal stabilizer fuel, because then we do take that to 6 units, and that's for stabilizer trim fueling. But if you're on a freighter, you know, something, or a passenger airplane that does not have horizontal stab fuel, then no, you don't have to set the trim at all. But you got a horizontal stab tank, yeah, 6 units. And that's gonna correlate to the mark on the tail. There's a mark on the tail that shows where the stabilizer is in relation to 6 units, and that's for fueling. So you can tell it's kind of out from exterior. You can tell that it's properly set for fueling. It's common in the airplane world, TQ2, I meant to say, 2set 2000. It's a reminder you don't have a clearance, so it's like 1200 in the general aviation and corporate world. It's just that we use 2000 instead of 1200. And that's what most carriers do. It's just a reminder you don't have a clearance. This was on the, I believe, electrical power down procedure. You can just turn the APU off. You don't have to unload the generators. And so no need to unload and then turn the APU off. It's just turn the APU switch off. And that's because there's an APU controller, so that computer controls everything for the sequencing for the shutdown. So it's going to unload it and do the things automatically like that. Homework and video, and you said that's okay. You found the homework. You know that the video thing is was suggested early on in the live streams that I did, and most people found it kind of hard to do. You know, to film yourself and then make a recording and put it together and edit it and things like that. So some people did it and they did it for a couple lessons and they said, oh man, this is too much work. So it's not necessary to do the video like lessons. I just thought if somebody wanted to do it and they want me to critique it and look at it and that kind of thing, that's fine. But most people didn't do it, and maybe 2 or 3 did, and then they did it for maybe a little while and then stopped because they found it was just too much work. And I agree, it is too much work. It's too much work to do a video. I found that out when I did the live streams, where you record, to do even like what I'm doing here, putting everything on a screen and then talking to it, and then you got to edit it. And well, I'm not editing this, but that kind of thing. So it's always something of a process to do videos, and everybody's that are viewing my video are probably working and they're doing it for fun, and they probably figure I don't need to do homework for something. I'm just trying to learn the airplane a little bit. So even though I'm kind of comprehensive in the course, people take out of it what they want to take out of it, and that can be bits and pieces or segments, and maybe not caring so much what the flows are or airline operation, but it's meant to be an airline operation from lesson 1 to lesson 10 and preparing you to get into the full flight simulator. So that was kind of how it was promoted. It wasn't promoted as a focused shorter segment. It's like a course if you were training yourself. And so if you wanted to do the full bit, then you fly all the scenarios and try to make it just like you were with me and doing it. But otherwise, if a person doesn't have time to do that, that's fine. Anyhow, that's it. If there's any other questions, shoot them, or if there's something I said that you don't understand, shoot them back. But they were all good questions, and hope you have a great time on your trip where you are all over the world. See you later, Goose. Bye.